Welcome to qnawire.
For problem 5.109, we are looking for the center of gravity of this basket, which means we'll need to find the centroid in the x, y, and z direction. And to do that, we'll use this equation, where the centroid times the total area of the basket, since it's sheet metal, so we can use simply the area instead of the volume, is equal to the sum of the centroid times the area of each component. We have four components. We have the quarter circle base, we have the curved piece at the front, and then we also have two rectangular pieces, which I'll label 1 and 2. And I think the easiest way to go about this is to make a table where we find the centroid of each piece and sum them together. Now the centroid in the x direction for the first rectangle is simply going to be half of its length in the x direction, which is 5 inches, since it is a rectangle. The second rectangle lies completely on the z-axis, so it's going to be at 0 inches for its centroid in the x direction. Now the curved piece is a little bit trickier. If we look at this curved piece in the xz plane, so we're looking from the top, we can find its centroid by integrating, looking at a little sliver and adding them all together. So looking for the centroid in the x direction of this curved piece, it'll be equal to the integral of a section of x times the change in length over the integral of the change in length. Now to find x at any point along that curve, it'll be equal to the radius times the cosine of its angle, and the change in length is equal to the radius times the change in angle, because that's the arc length formula. And plugging that in, we get that here. I'm going to make a little more room here. So plugging both of those into the equation, we get that the integral of r squared cosine theta d theta over the integral of the radius d theta is equal to the centroid. And then since it's a quarter circle, it's going to go from 0 to pi over 4. And taking the integral, we get that the centroid is going to be equal to 2 times the radius over pi. So then going back to our table, plugging in 2 times the radius over pi, we get that is equal to 6.366 inches. And for a quarter circle, the formula is 4 times the radius over 3 pi for a centroid, which is equal to 4.24 inches. In the y direction, it's a little simpler. The rectangles are going to be half the height for the y centroid, which is 8 inches. And that's going to be the same for the curved piece as well. And the quarter circle lies completely in the xz plane, so its centroid is at 0 inches in the y direction. And for the centroid in the z direction, This time, the first rectangle is all in the y-x plane, and so its centroid is 0 inches. And the second rectangle is going to be half of its length, or 5 inches. And we can use the same formula for the curved piece, because the quarter circle goes between the x and z axis, so it's symmetrical in that way. As well as the curved section. So they're both going to be the same x and z centroid. Now next we'll need to find the area of each of our parts of this composite body. So the area of rectangle is going to be its base times its height, which is 10 times 16 inches, coming out to 160 inches squared. Both the rectangles are the same size. Now the curved piece, the formula for its area is going to be its arc length, which is pi times the radius over 2 for a quarter circle, times the height of that curved piece. And that comes out to 251.3 inches squared. A quarter circle is pi r squared over 4, which gives us 78.54 inches squared for its area. And we'll need the sum to plug into our equation to find the centroid of the overall basket. So summing together each column, or row rather, we get this value. And the last thing we'll need for our equation is the centroid of each component times its individual area. And we'll just take the values for the centroids of each component from our other table that we just calculated. And so now it's just plug and chug to fill this in. And we also need the sum for the equation. For the right side of the equation, this will be. And I mixed up the columns here, so I'll just replace that real quick. Now we can use the equation I introduced in the beginning, where the centroid times the total area is equal to the sum of the centroid of each component times its individual area. So plugging in the area on the left side, and then the sum of a centroid times the area of each component on the right side, we get that our centroid in the y direction is equal to 7.03 inches. And for the x direction, we'll use the same equation. And if you notice, the area and the sum of the areas times each centroid are going to be the same for the x and y direction. I mean, the x and z direction are the same, which means that this answer for the centroid in the x direction is going to be the same answer we get for the centroid in the z direction, which makes sense because they are symmetrical.